Hi viewers, I am Muhammad Kamruzzaman and you are watching my YouTube channel Corey's Industrial Electronics. Viewers, my channel is a Pakistan based channel and its language is Urdu, and this language is used in India, Pakistan and Bangladesh. I have made one video on PLC Micrologix 1000 and the aim was how to wire the PLC, how wiring is made of PLC for the inputs and outputs. One of my viewers has commented me today. His name is Mr. Phlilip Pierce. Thank you, Mr. Phlilip Pierce. He has commented me, I'm trying to follow as best I can. I just don't speak Hindi, sadly. It means Mr. Phlilip is trying to understand my video for the wiring of PLC, but he is unable to understand as he is not aware of this language and is not used to. So I have decided that I should make a video in English language for the viewers who cannot understand our language, that is Urdu or Hindi language. So today I will try to tell you more about the Micrologix PLC. His model is Micrologix 1000, and in that video, that was lecture number 8. That video, this was a PLC, and this was a power supply. These were the switches, 3 switches, and a one multimeter, digital multimeter. Okay, so I will try to replicate the same procedure as I had told you in lecture number 8 in English language. I will try to let you know and try to let you understand that how PLC has to be wired for the inputs and outputs. Okay, first of all, I want to let you know about the model number of the PLC I has used in lecture number 8. The model number was, which is called catalog number, is 1761-L32BWA. Here is a format from the OEM, that is Allen Bradley. L20 or L32 means L is a base unit and 32 is the number of inputs outputs, that is 30 IO. B is for 24 volt DC input signals. It means in this PLC we will provide input signals of 24 volt, that is a digital signals. And after that, W is a relay output. Output type is relay. BW, and A for the power supply. Which kind of power supply is 240 or 120 volts AC. So we are talking about a Micrologix PLC which has 32 IO and is operating on 220 volts, 240 volts, and input signal is 24 volts and outputs is relay base. Okay, here is a diagram or picture of the PLC. This is a small PLC. This is not a L32 model. Here this port is for the priming port, which is RS232 communication channel. These are the status LEDs for the power, run, and force. And the above these LEDs are for the inputs one, and these LEDs for the outputs one. These two terminals are for power application to operate this unit, and these two terminals are the 24 volt output for the safeties. Okay, these diagrams I have downloaded and printed from the Allen Bradley website, and this is a user manual for the Micrologix 1000. So we wire the inputs, these two pictures, one and the second one is the input terminals of the PLC. We can wire two types wirings, which is sinking type or sourcing type. Okay, sinking and sourcing circuits, and the detail is given here. As you know, sinking means sinking in, something is going inside. Sourcing means something is coming out. Okay, if our power is going in the PLC, we will say that this is a sinking input, and if power is coming out from the PLC, we will call it sourcing out or sourcing input. Okay, what is the definition of the sinking input? The input energizes when high level voltage is applied to the input terminal, that is called active high, and connect the power VDC to the Micrologix DC-COM terminal. And sourcing input means the input energizes when low voltage is applied to the input terminal, that is called active low, and connect the power VDC positive to the Micrologix DC-COM terminal. Okay, here is an example. First of all, I must let you know that these terminals are the input terminals of the Micrologix 1761L32 BWA for which we have demonstrated in lecture number 8, and today we are also talking about the same. Okay, first of all, these two terminals are the positive voltage output. Okay, when we will supply 220 volt or 120 volts input power to the PLC of this model, like here, this is the bottom one, this is the output terminals, these are the input terminals. Okay, when we will apply the power 220 volt, that is 85 to 264 volt AC here, then this PLC has two PCBs. Number one is power supply in it, and one is the processor or interface board. Okay, power supply will also output 24 volt DC for the uses of here for the inputs. But in that video I have recommended that please do not use this output power of the PLC, as if you short anywhere at the input, you are going to lose or you are going to make a defective this whole PLC. So use a separate power supply, just like I have demonstrated in the solar 24 volt power supply. So please, if you can have a power supply, use that power supply. If you don't have, then you can use these terminals with care. Okay, the inputs of this PLC has two groups, number one group, number two groups. One group is used for input number 0, input number 1, input number 2, and input number 3. And for these 1, 2, 3, 4, these four inputs, we have a DC common terminal over here. And for all the inputs, we have DC common terminal over here. Okay, if you see that if you are going to use a sink or source, I will let you know on the second page as earlier over here. Over here you can see DC terminal has been provided with DC minus. So connect the minus terminal of the power of the PL or the power supply over here minus. The positive terminal will go in the field, and these are the switches. Positive terminal will go there, and when the these switches in the field or at the machine will make, then positive will come over here in the PLC. So what is going on? Positive voltage or positive 24 volt positive signal is going in the field to the switches and coming into the PLC. So what is going on? positive volt or current is coming toward the PLC and going inside the PLC. So this will called sinking inputs, because in general conventional current always we assume that positive current flows from positive to negative. So the direction of the current will be like here. From here positive voltage will come out from the power supply, will go and then will come into the PLC from these switches. So voltage or current is going inside of the PLC. So this process will called sinking of inputs. And what about the sourcing? For sourcing, what will happen? This is a DC common terminal for the second group. We will apply positive at the common and negative or 0 volt like here to the all switches of the inputs in the field. So this positive voltage is at the common will come out from these input terminals, will go to the switches in the field at the machine, and after that from passing these switches, this positive voltage will go to the negative of the power supply. So current will come from DC common terminal, or you can say that from the PLC current will come out to the switches and will go to the power supplies. This is called sourcing, as because current or positive current is coming out from the PLC's inputs. So this will called sourcing inputs. Okay, what happened in our that video, that is lecture number 8, we have used a power supply, a separate power supply. We had not used PLC's power. 220 volt, 230 volt we have given from here. We had used 3 switches, switch number 1, switch number 2 and switch number 3. Switch number 1 was normally closed switch, switch number 2 was normally open, and switch number 3 was normally open. And what I have suggested, that DC COM has been connected at the minus terminal. Over here minus is coming and positive is going to the field and coming in from the switches in the input number 0 and input number 2. So this configuration is sinking inputs. These are sinking inputs, as positive voltage is coming into the PLC. And the second one, we have provided a sourcing, as positive voltage from the power supply we have provided at the DC COM, and this positive will come out from the input number 4, and when this switch will make, it will go to the minus supply. So in the input we have demonstrated both the sinking inputs and the sourcing inputs, as already I have told you. So if you understand, I will be very happy. Thank you very much for watching my video, and I will say goodbye for the next video.